Welcome to Inside Builder channel. Big data learners, data leaders, and my dear friends. Advanced Spark SQL techniques, exploring window clause in Spark SQL, unleashing the power of data analytics. So what is the challenge at hand? The challenge at hand is to create sequential aggregations. The window function is useful when you want to understand the change or to rank the value that is available to you across time or across a particular partition or across a category. Second, as I was telling, the ranking of certain entities with relative to time and arbitrary data point. Unlike group by, new column that is created by window operation can coexist along with the existing data. So you don't need to completely drop the columns that you are not aggregating on. So these are some of the solutions that window functions provide in Spark SQL. This window function is very similar to what you see in PostgreSQL and MySQL. There could be minor changes. However, the clauses, the functions that is available inside the window functions like ranking, analytic functions, and aggregate functions are very similar. We have the rank, dense rank, percentage rank. We have cumulative distribution, lag, lead, and first value, last value. We have max, min, count in case of aggregate functions. We'll be seeing a couple of these functions in action inside the Kaggle environment. So we will start as usual with the Kaggle notebook and create the data that we want to work with, and then execute the functions and understand how it is solving the problems, and then troubleshoot if there is any issue that arises. So the Kaggle notebook that I am sharing here the link will be shared to you guys in the YouTube description. Do take a look at that. Just once you click that particular link, you will be taken to the Kaggle notebook. The point of sharing the Kaggle notebook along with the data set is so that it will be much easier for you guys to practice. That is one of the primary goal of creating such videos, including the Kaggle notebook. What happens in my when I was learning big data, the challenge, or for that matter, not just big data, for that matter, any of the data analysis activity, the data set that you are going to work upon is very important, very crucial, in fact, because all the functions or the transformations that you are going to do depends on the base data, right? And if the base data is not correct, and whatever you are trying to do on that particular data will not match with what the session is talking about, or what the video is talking about. To avoid that completely, this kind of providing the Kaggle notebook directly is one of the solutions that I was thinking, and I am sharing this. I hope that you like this video and this content. Do leave a like and share it with others. Subscribe to my channel so that further updates on big data and Python library related videos will be uploaded, and whenever I upload the videos, the update will come directly to your YouTube dashboard. With that introduction, if you guys are new to big data and related technologies, I would suggest that take a look at this particular Learn Data Engineering and Problem Solving playlist. This will give you an overview of not just big data but entire ecosystem of big data along with Python. Or you can also take a look at building a powerful data pipeline with AWS Athena. This also provides the very good introduction. With that said, let us head to the Kaggle notebook that I'll be using. This particular Kaggle notebook, as I always say, that you don't need the Spark cluster for working and understanding data manipulation language, that is DML inside Spark. So you can use PySpark to work with various DML functions, and window is one of the DML functions. Here I am installing PySpark, which is not by default installed in Kaggle environment. You need to install it. Following that, you need to get the Spark session up and running. This is very simple. These are all regular things that I'm not going to really explain here. I am creating a separate database. From here, I am creating a table called employees with name, department, salary, and age. This particular example table is taken from the example that is provided in Spark SQL documentation. You might be wondering, so what is the difference, Kamal? The difference here is that I am not going to follow whatever they are showing in the examples. So what I do is I try to break whatever commands they show in the example. Why I do this?
because what happens is when you try and break the examples that is given, right, you will know, you will understand much easily what kind of commands you need to modify. So I got this is not my idea. I got this idea from someone else when I was reading about coding. So they were telling that whenever you want to learn coding, you have to change the variable names. So for an example, if the example says that variable name should be alpha, you use the example, you use your variable name as something like A or B. So what will happen is, everywhere the alpha is provided in the example, you will have to use A, or you will have to use B variable that you're choosing. So immediately what will happen is, you will have to keep track of the entire program, and whenever you miss something, the program will break and you will have to fix it. So this idea will actually, it takes you really far. So unfortunately I don't remember the person, but I really thank that person for sharing me this idea. But yeah, I'm using it in a different way. So this is the example table that they have provided. Here itself, I don't exactly insert the tables as they inserted. So I take insert it as a single command here, and I use SQL. So this SQL is basically Spark.SQL. So I have actually assigned the Spark.SQL method to SQL variable, and then I am executing these things, and you'll see that once I select it, you will see the employee table getting shown here. Just review the employee table once. So the names are individual, so individual names, but the department are common. So there are some of the departments that is common, and the salary again is there are some kind of overlap there, and age also can be used as a category. But here age will not play much of a role here. You can actually try it out. That is one of the practice that you can try. I will give you some ideas about that. First and foremost, let us not forget group by. We have all cut our teeth with group by, right? And we know how troublesome it is. So you will see that I take this particular table and I send it through a group by activity, and you will get three rows of data. So I am having engineering, marketing, and sales, and I group by across that department column, and as you can see, I get the department salary. But if you want to actually take this data, for that matter, take this table and then attach it to this table. So what I mean to say is that, for an example, if I want to take the department salary, the cumulative sum, not the cumulative sum, actually this is a sum, and if I want to show it here, along with engineering. So think what you have to do. First and foremost, you have to create this transformation, and once you transform it, you have to either use select table, you have to create a table on this transformation, and then you have to think about joining based on this department with this particular table. So you have to do multiple things. So group by can be very cumbersome to operate upon. That is where window comes. So if I am going to do the same thing with window clause, okay, so when I'm going to use the salary as individual salary, so this is the salary that I am already having, but I am going to do a sum salary over partition, and partition is, so there are two functions inside window function, that is partition by and order by. You will have to use partition by. You cannot escape this particular clause, but you can always skip order by. So that will not throw an error, but if you skip partition by, it will throw an error. And the syntax, as you can see here, once you give an aggregate function, immediately you should follow it with the over clause. This over clause is going to tell, okay, on which partition this sum salary should be executed. And then here I am doing a window. So whenever I am using over clause, the window function starts initiating. And so partition by is on department. So here immediately you'll see that I am ordering by salary, and salary by default is in ascending order. The order by is sorting on ascending order. So you see the individual salary, it is coming as 21, 23, 29. This is in ascending order in each of this partition, not ascending order inside each of this, not ascending order inside the every step. So you might be wondering, okay, Kamal, here there is 1000 here, so how it is ascending? As I am telling, no, it is not ascending on the entire data set. It is ascending on the partition. So sales will be separate partition, marketing will be separate, engineering will be separate. and on top of it, this sum will do a cumulative sum. So this is not the aggregation that you see in the group by. So in group by, what happens, it does a single aggregate sum, but here it is a cumulative sum. It starts with 21,000 and then it keeps on adding. You can actually bypass this. Okay, what you can do is you can use something called as window preceding rows. So current row to preceding rows and current row to following rows. That is a concept that we will be seeing. But the point here is that once you use current row to preceding rows, what will happen is it will do a same kind of a group by, a same kind of activity that group by does. In this case, I am not going to do that. I want to show you the cumulative function because there are a couple of reasons for that. If you see here, the first one, 21,000 is 21,000 plus 0 because it's the first one. But the second one is little tricky. You see, the second one has two 23,000s. What Spark SQL does is it actually adds them together and it creates 67,000 as a single row, okay, a single value, and then it repeats them. So it does not actually. This is not intuitive. So some of these gotchas are not, when you think, when I as a developer think, I always think, okay, so if there is 21,000, the next value should be 44,000. This will be what I think. But Spark SQL thinks in a different way. So Spark SQL takes the next two 23,000s, adds it to 67, and then provides the value. So this could be difficult if you have not practiced. Okay, and yeah, the last one, 67,000 plus 29 is 96,000. That is very clear, and you can see how the group by is happening and how we can actually compare each of these values. You can also do a lot of other regular mathematical activities on these columns. So that is not something that I am really going to concentrate here. My intention is to talk to you about partition by and order by. We will see what is going to happen next. So as I was telling, I'm going to break the examples. So this is the first break I have done. The example usually will have order by. So what if you don't? So if you don't have an order by, it will by default change the order. Okay, by default the order will be random. It will not maintain any kind of order, and you will see what is happening here. Once I remove the order by, you will see the complete aggregation happening. So it's a very simple change. Sometimes what you will think is, okay, I need to use that unbounded, preceding, unbounded, following, etc. Sometimes all you need to do is just remove certain clauses or constraints. So yeah, this is what I want to talk again. These are all constraints that are placed on top of the calculations. So you are going to do a calculation. I'm telling that, okay, this calculation should be constrained by partition and constrained by the sorting order. So this is thinking of this kind of thinking is very important. When you are, so sum, for an example, let us take a simple example. So summing or aggregating is a calculation. So the calculation can be unbounded. So there can be no constraints at all. So you just say, okay, do a sum of the salary, and like how you do on group by, it will directly do the sum of all the values and give you the aggregation. But now I'm telling, I'm telling to SQL that partition the tables, not physically. So hypothetically partition the tables based on the department column, and then I'm asking that, okay, give me a sum, and that to a cumulative sum, because I don't even need to say it's a cumulative sum because I'm giving the order by value. When I give an order by clause, it by default becomes cumulative. So why I'm saying this? Think about it in a logical sense. Whenever you are going to say, I need to order it in a descending or an ascending order, so the program written on top of the sum window sum clause is written in such a way that, okay, if someone is going to ask you to sort, then do a cumulative sum. If someone is not going to ask you to sort it, then do a full sum. You see this, right? This is the difference that you have to understand, and only when you break it you will understand. So that is one of the things, and you can always use order by descending, and you'll see that this becomes different. So last time you saw 67 and now you are seeing 75. Why is that? Because now you are seeing 29,000 at the top, so it is coming in descending order. By default it is in ascending order. Okay, so I hope that you guys are catching hold of the important parts here.
window functions and analytics that you do with window is sometimes considered very confusing because of this order by, partition by, and the overclass. Actually, it's not. It's one of the most easiest functions that you can ever have in SQL. And if you master it, if you know how to work with it, believe me, all the analytics activity that you are going to do will become extremely fluent. Why I am saying extremely fluent is because, think about it, you will have the entire columns in front of you. You will have the individual columns and you'll have the sum also. And you can see the data in front of you in numbers and you can compare it. And what better way to understand the data? Also, there is a concept that whenever you are going to analyze the data, right, you have to become one with the data. See, to become one with the data, you need to do a lot of transformations, and a lot of transformation in different format. Not that you take you do the transformation in group by doing sum, doing multiplication. That kind of transformation, mathematical transformation, may or may not provide you the insight. But when you're going to do transformations that involves windowing, the transformation that involves ranking, transformation that involves group by, such a kind of a wide varieties of transformation, that will provide you a different perspective. So that is also one of the reason why I'm talking about this here. Okay, lead and lag. So lead and lag, again, it's about leading and lagging the data inside the partition. So here I am not showing the partition, however the partition can be shown. So if for an example, all I need to do is add department. Just a minute, let me confirm that. Yeah, I have to add department and give a comma here, and then you will see the department here. So it is as simple as that, but I did not add it ahead of time. This particular point, you can see it is lagging, and here it is leading. This lag and lead can be modified. I would suggest that try to play with this. See what happens with this number and this number. I am not going to explain to you what those numbers are. Okay. See, theory. There is lots of theory in this world. There is lots of documentation available in this world. But the challenge is that intuitively understanding what a function does is more important than reading something and understanding it. It is a benefit of computer science, and it's a benefit of such an interface that you are having, that you can try as much variables or as many changes as you want. Yes, if you're a programmer in 1980s, you cannot use this method, so it's not going to be possible. But in 2023, it is how you have to learn programming. So the more you try it, the more you practice with it, more you change things, more you break things, you will start learning really fast. In fact, the entire businesses are running in a format of breaking things and learning. So why not programming? So try to work with this and add these numbers in salary and see what happens, why it happens, and change this number 0 to something else. Give a string to see whether it can accept. And then once you do all these things, then go to the functions, then go to the documentation and see whether your intuition and what the documentation is saying is correct. When you have that kind of a dialogue with the tool, with the application, then you will start falling in love. So that is something that I always talk about. This is something that I wanted to share you guys with regarding lead and lag. Now comes the interesting part. So there are two ranking options. So there is a simple rank and there is dense rank. Initially, when I looked at this, it was little unnerving for me because I was not able to understand what is changing here. In case of rank, okay, so here I have already partitioned by the department and I am ordering by salary. So this is something I have been doing for the past all the examples. So in this case, instead of using any of the aggregation value, I'm just giving a rank. I'm calling a rank function. This rank function, what it does is it goes into the values and it checks. So in this case, I am already ordering by salary and I am not giving any value here. So it is by default going to be ascending. So you see this in reality, when we look at the rank, we look at the top value as the first, but in case of this particular class that we are using, the last value becomes first. Not only that, this is something that we already saw, that how Spark SQL finds it. So by default, rank provides the same ranking value for the values that are equal.
So in case of 23,000, it gives both 2. The difference between dense rank and rank is at this point. So if there are multiple values that are same, then it gives same rank values, but the next value that comes, it is given the next value. So you explaining it is very difficult, but if you see here, it's 1 2 2 again. So this is actually 3 numbers have already passed, the 3 ranks have already passed. So 29,000 will be the 4th rank. Okay, this is in case of rank, but when you come to dense rank, it does not do like that. So in case of this dense rank, what happens? It is 1 2 3, but only 2 ranks have been allocated. So first rank has been allocated and second rank has been allocated. So the third rank is allocated to 29,000. This kind of changes. So some places you will need such kind of a requirement. So you might want to work with a data set which wants to categorize the salary into 1 2 3, and then you want to do a group by probably on 1 to 3. So you want, say for an example, you want only the third ranks or fourth rank in all the fourth salary in all the departments, or first salary in all the departments. So at that time you might actually get more first values also. So that is also something that you need to be concerned about. And think about it, if someone is asking you, okay, tell me the second ranking salary in this department. So what will you be saying? What is the second ranking salary? It is very clear, right? In second ranking salary, it is 2. No doubt in that. So whether it is dense rank or whether it is a simple rank, it is 2. But when someone asks you, okay, what is the third rank? Then it becomes confusing. In case of rank, there is no third rank at all. But in case of dense rank, the third rank is 29. This is how we think. Humans think like dense rank. We think, okay, so there is 21,000, there is 23,000, and there is 29,000. So dense rank is very much intuitive for us, but the rank is little bit unintuitive. So these are all called as gotchas in various applications that we day in and day out work. Spark has its own deal of gotchas. So the reason why I am giving you a simple example and asking you to break it is very simple. The more you try to understand with a simple problem, what you can do next is, when you are practicing with a bigger problem. Yeah, let me go back to the browser. That's very important actually. This particular Kaggle notebook comes along with the data set itself. So you don't need to go and search for a data set. There are lots of data sets here. You can take any of these data sets and you can start applying these concepts on any of these data sets. You might have to understand a couple of things about how to work with this Spark environment. So there are playlists for that. You can take a look at that if you want to understand. But yeah, you can use this data set and start pulling in this CSV files into Spark environment, and then start applying the window functions on this data. So for an example, if you go to DMart, in DMart you will have product list, or you will have sales. Sales is pretty interesting. So let us open sales and let me show it to you guys. So here you see sales has lots of information like ID, we have GMV, we have units sold, and all these things data is there, and you have units sold. So what will happen is you can work on window function on units sold. And also I think product analytic vertical, and we have MRP also. So you can take those values. So you can take select all, just go down a bit. It's little cumbersome here because I have zoomed it in, so that's why it's a bit difficult here to manage. You guys can open it and you can start working on this particular data set. This is a very good data set to practice window function, and you don't need to go anywhere. It's already there, right? All you need to do is pull the data into Spark environment and start working on it. And there is finance health also. This is a data set which is continuously updated, and this, I think it is coming from World Health Organization. I don't remember exactly. You guys can take a look. And this is one of the Airbnb data set. I have taken separate videos on Airbnb data set specifically. You can take a look at listing details. This is pretty interesting to work with these window clauses. And so I hope that you guys got a hang of what is window clause, what is partition, and how you use the over clause along with window, along with the order by. All these things I hope that you guys understood. So as I always say, practicing is more important. I hope that you like this content. Do leave a like and share it with others. Subscribe to my channel. So further updates on big data and related technologies, not just big data, related technologies like machine learning, artificial intelligence. All those topics will be, videos will be uploaded. And once you subscribe, the upload information will come to your YouTube dashboard directly. With that said, I would like to take a leave with 4 words as usual. That is practice, 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 practice. See you guys. Have a great time.